So yesterday when the bell rang, we were busy, or we were about to look at proving similarity when I get told that they are parallel lines. So as soon as I get told they are parallel lines, I am going to use that. So let's make a note on that. Today we are AWY in Group 1 and it is Thursday. And it is the 10th of September. Yes. You're not supposed to, but I think that's causing trouble. So quickly, proving similarity. Remember, it's the three lines going down when parallel lines are given. So if your parallel lines are given to you, you can use your F, your U, and your Z. And it is more likely that you're going to land up using F and Z than you are using U. But that doesn't mean that U can't come up. So remind me, which of the three reasons is F? Corresponding angles, and they are? Do they add up to something? Are they equal? They are equal. And remember, we have to add the parallel lines. My U, are they equal? They add up to 180. And my Z is my alt angles, and they are equal. Okay, so we can use those three things if we know that they are parallel lines. If they are not parallel lines, you cannot use them. So some of you try to use it with the previous question yesterday. If it's not there, you can't use it. So that's very important. No parallel lines. No reasons can be used. Even though we are very tempted to find alternate angles and corresponding angles, if the parallel line is not there, you cannot use it. So these are the no parallel reasons can be used. I would highlight that and write it very big and bold. Because just like yesterday, you're going to try and use it. So I'm going to do one or two that's not on the diagram first. Then we'll do the one that's on the diagram. So let's do an example. Oh, ruler. There's my ruler. my picture on the board, as it stands, can I use co-interior, corresponding, or alternate angles? Who says yes? Who says no? The rest of you, let's look at the board, please. Stop drawing just for 1 second. Look at the board. The picture that I've drawn. Can I use corresponding, co-interior, or alternate angle reasons? Who says yes? Who says no? Why are the rest of you not doing anything? If you don't know, choose one. Who says yes? Who says no? Only 2 of you are correct. I did not tell you that I had parallel lines. There are no parallel lines, so you can't use co-interior, corresponding, or alternate. You'll have to use other reasons. Maybe vertically opposite, and I don't know what else. Only now, when I say AB is parallel to DE, now I can use co-interior, corresponding, or alternate angles. And that's all the information I'm giving you, and I want you to prove. And I'll tell you which the angles. Prove triangle ABC and triangle EDC similar. So since I gave you the triangle names, you can more or less work out which angles should be equal. We must be able to prove that A is equal to E, B is equal to D, and C is equal to C. So we're going to start with our format. In triangle ABC and triangle EDC, what can we say? What can we find? Yes, Rio.
AB is equal to D.
So you're saying this line is equal to that line. How do you know that? The arrowheads tell me they are parallel, not equal. If they were equal, I would give a little line going across. Keenan?
AB, ABC.
This angle?
Yeah, and EDC.
EDC. What reason would you use?
It's given.
No, it's not given. Thank you, Leikona. It is alternating angles are equal because there's my Z. I'll even highlight it for you. There's my Z. Alternating angles are equal. So let's write that down. So using 3 letters, I like that. A, B, C is equal to E, D, C. Alternating angles are equal. Which lines are parallel? And D, E. Fantastic. So that's one angle done. So I'm going to do it in pencil so I can erase it. I've proved that angle and I've proved that angle. I've only done one thing so far. I need to do 3 things to prove similarity. Keenan?
ACB.
That angle.
ACB and DCE.
And that angle. Reason?
Corresponding.
No, vertically opposite angles. So ACB, ECD, vertically opposite angles are equal. So we proved this one. I'll draw a nice star. Now what? I have 2 angles in each triangle. What do I do about the third one? Did this yesterday, Rio? No. Lekona? Interior angles, and I told you we can also call it something else. Does anyone remember? Keenan? No, not exterior angles. Yusuf? The third angle of a triangle. So we would say BAC is equal to DEC, and you can use interior angles of triangle, or you can use third angle of triangle. So now we've also proven that this angle is equal to that angle. Was there something else that we could have used instead of the interior angles? Instead of that? Remember we have parallel lines, right? I could have used alternate going in the other direction. So that would have also been perfectly good as an answer. So we have 1, 2, 3. What is my last statement when I prove similarity, Keenan?
A triangle ABC is similar to each triangle ABC and bracket angle.
Perfect. Absolutely perfect. There's one more example I want to do, and then we're going to try number 5 from the worksheet. Okay, that should be more than enough time for you to have copied that down. Anyone busy, Erin? Dylan has a voice. Thank you for caring about it and for him. Just lock it here. Okay, Dylan can fit. Anyone else? I think we're all here all week, which is Dylan. Okay, our second example. I'm also going to draw one. Okay, there's my 2 triangles. I'm going to call it PQR and PST. it stands, can I use corresponding, alternate, or co-interior? Even though it looks parallel, I cannot assume. So right now I would have to use other stuff. I would have to use common angle, and then I can't go further because I don't have any more information. Okay? But if I do this, only now can I use co-interior, corresponding, and alternate. So let's do our format. In triangle, PQR, and triangle, PST, I need to prove 3 angles. And I'm going to try and prove that P and P are equal, Q and S are equal, and R and T are equal. So the names help me to find out which angles I need to prove. So now I just need to remember my reasons to try and prove it. Anyone want to say start for us? Okay, Keenan?
Triangle PQ, triangle PQR.
You mean the angle PQR?
Yeah,
Okay.
PQR is equal to PS times PSD, and these are co-interior angles.
But co-interior angles would be the U, right? But remember, it would be together on the inside. So I'll show you the U. In order to use co-interior, it would be these 2 angles. Is that what you're trying to say, Alita? There we go. So you had your angles correct, Keenan. So it is definitely PQR and PST. But as Alita just told us, it is my corresponding angles that are equal. The F, there you go. So there's my F. So that angle and that angle are equal. And which are my parallel lines? There we go. So that's only 1. I need 2 more. Yes, Rona.
P or Q is equal to PTA.
Your reason? I didn't ask you. So, well, how did you see it? What did you see when you saw it? You saw F, right? A back to front F. So what is my F? Corresponding. Don't doubt yourself. And my parallel lines are still QR and ST. Now I want the third reason, but you are not allowed to use interior angles of a triangle. So what would I use instead? Keenan?
Third angle.
That's the same as interior angles. I don't want that one. I want a different one. We learned about it yesterday. When they are exactly the same angle, what do we call them, Likona? A common angle. So you can just say angle P is common. So we have 1, 2, 3 sets of corresponding angles equal. Therefore, PQR, the triangle, is similar to triangle PST, angle, angle, angle. So yes, you definitely could have used third angle of a triangle or interior angles of a triangle. Common to both triangles. Okay, I want you to try number 5 by yourself, please. Number 5 from your worksheet. Okay, once you finish copying, you try number 5 from your worksheet. Number 5, the one with the 2 triangles and the parallel lines, this one. Give you another minute and a half. Okay, let's have a look on the board. So I get to see, or I can see that KJ is parallel to LM, and I can see that MN is parallel to JL. I can see that because there's double arrows there and single arrows there. Now, very important, parallel lines do not mean that they are automatically equal. You need the little line for that. Okay? So if I have parallel lines, I can use the 3 reasons that parallel lines give me. So I can see a Z here, which tells me that this angle is equal to that angle. Does that help me? Does that prove anything about the 2 triangles together? No. I can also do this Z here. That angle and that angle are equal. So that also is not going to help me. I can see a U telling me that this angle plus that whole entire angle. Again, not helping me. Okay? What I can see and what can help me is that I see an F here telling me that this angle and that angle are equal. And my lines that I've used are K, J, L, M. So we write that down. That's my first one. Angle JKL is equal to angle MLN. And it is always below those lines. Okay? Don't get confused and think it's this side. That is co-interior. It must always be the same side of that line. I'll show you the full answer in a moment. Okay. Then I'm going to also see that I have an F going in the other direction. But now be careful, because the parallel lines that I've used have changed. I'm now using JL and MN to find my F, telling me that this angle is equal to that angle. MNL is equal to JLK. Now if I have that angle and those 2 angles, what can I say about the third one? Third one is also equal because the third angle of a triangle. So there is my full answer. So what I did first was I didn't know how to call my second triangle, so I haven't actually named it there yet. I wrote what I could see. JKL is equal to MLN. Corresponding angles are equal. KJ parallel to LM. Then I could see JLK is equal to MNL. Also corresponding angles are equal, but now I've used JL and MN. And the last one, I can just say that KJL and LMN are equal because of the third angle of my triangle. And then I could match. I could see that K matches with L. So K matches with L. J matches with M. So J matches with M. And L matches with N. So L matches with N. Yes, Erin.
Ma'am, I did it in the right way, but I put it in the wrong order. So I said KJL equals to LMN first, and then...
So they all correct, but they're in a different order. Yes. That's fine. That's perfectly fine. So it's obviously what you see first, that you write first. Okay, look at number 6 for me. Tell me, is it or is it not similar? Are all the angles equal? Yes, Erin. They can't be, okay? So therefore those 2 triangles would not be similar. Just waiting for people to finish on the board. Who's still busy with the board? Okay, moving on. So, we have triangle ABC and DEF are similar. So according to the names of the triangles, A should be equal to D, B should be equal to E, and C should be equal to F. But I can already see that A is not equal to D, and B is not equal to E. And even if we calculated the interior angles, that would be 40 and that would be 50, C would not be equal to F. So therefore they cannot be similar. It's just two random triangles. And that's all you say. But she wants to know with reason, so we would say A is not equal to D. B is not equal to E. And C is not equal to F. Therefore, not similar. So you would say triangle ABC not similar, triangle DEF. You finished with the pink? So I'm going to write it out properly now. I just didn't have enough space there. So number 6. In triangle ABC and triangle DEF, angle A is not equal to angle D, and if you want to use 3 letters, I'll call it BAC and EDF. ABC is not equal to DEF, and ACB is not equal, I'll show you now, to DFE. Therefore, triangle ABC not similar to triangle DEF. So that is what it would look like. So the fact that I am saying not equal is my reasons. And lastly, corresponding angles not equal is my final reason. So now we're going to move on. So we know how to prove triangles are similar, but now we're going to apply that information. So if I have proven that they are similar, that means that all the corresponding angles are definitely equal, but the corresponding sides are also in proportion. So that is what we are going to apply now. And we are going to apply it to calculate the lengths of unknown sides. So I'm just waiting for people to finish on the board. We need to write a little bit faster, please. No, only at 5:02. So we still have 8 minutes. It's enough to write a note. Probably not to practice, but to write a note. Okay, moving on. Okay, so applying similarity to calculate unknown sides. So applying similarity to calculate unknown sides. So when triangles are similar, so triangles are similar, then angles are equal, so your corresponding angles are equal, and corresponding sides are in proportion. So looking at that diagram, we first going to prove that they are similar. Okay, so the example on page 4. So I know Ms. Saunders says that they are, but I'm going to say it again or show it. So in triangle ABC and triangle DE, if BAC is equal to EDC, and that's given to me. Triangle ABC is equal to triangle DEF, and that is given to me. And angle ACB is equal to DFE, and that is also given to me. Therefore, triangle ABC is similar to triangle DEF, angle, angle, angle. So I have proven that they are similar. So my angles are equal. What's wrong?
Now you could also see instead of ABC instead of EDF.
On top of the first one.
ABC, EDC.
Isn't it EDF?
I want A to be equal to D.
Yes, but I'm looking at EDC.
Triangle ABC.
It's supposed to be EDF.
Oh, F. Okay, thank you. So they are similar. Are similar. Therefore, sides are definitely in proportion. So now the problem comes in which sides are in proportion, and we can see it from my triangle names. AB must be in proportion to DE, and BC must be in proportion, so BC with EF. And AC must be in proportion with DF. And since they are all in proportion, it means that these divisions, these fractions, all have to be equal. So we can look at our values. I want you to fill those values in, so I'll do the first one. AB is 6. DE is 3. I want you to do the rest. What is BC? Write it down. What is EF? Write it down. What is AC? Write it down. And DF? Write it down. And simplify each fraction. BC 8, EF 4, AC 10, DF 5. If I had to simplify, 6 divided by 3 is 2, 8 divided by 4 is 2, and 10 divided by 4 is 2. Now this is what we use for the next questions, because what will happen is I will leave one of them out, and I will call it X or Y or whatever. So we will use the fact that all of them are equal to solve the unknown value. So I want you to turn over the page. We're just going to read. We won't write anything down. So they tell me that ABC is similar to EFD. So angle A must be equal to angle E. And angle B must be equal to angle F. And angle C must be equal to angle D. So AB, this side, is proportional to which side in the other triangle? My first two letters and my first two letters. So AB is proportional to EF, and BC, FD, and AC is ED. So we would write that down, which we will tomorrow. So we would say AC divided by ED, BC divided by FD, and AB divided by EF. We'll fill in the numbers and then we will solve. Okay, and we'll do that tomorrow. So you can pack up so long. So tomorrow we're only working from the worksheet. We probably won't write anything but the answers down.